Good morning, students. Today we shall learn Einstein's photoelectric equation. So Einstein framed an equation for photoelectric effect and successfully explained the experimental results of photoelectric effect. For his work on photoelectric effect and also theoretical physics, he was awarded a Nobel Prize in the year 1921. So let us begin with Einstein's photoelectric equation. So Einstein used the quantum theory of radiation to explain the photoelectric effect. So according to the quantum theory of radiation, radiation is made of discrete packets of energy called as photons or quanta. You can also simply say that they are just the particles of radiation. Radiation is made up of discrete particles called as photons or quanta. So what is the energy of each photon? So each photon carries an energy E equals to h nu, where h is a constant called as Planck's constant, the value of which is 6.63 into 10 raised to minus 34 joules second. And nu is the frequency of radiation. So before arriving at Einstein's equation, let us revise the two terms which we had done in the previous sessions. One is the threshold frequency nu 0, another is the work function phi 0. So I had told you that the incident radiation has a certain minimum frequency nu 0 below which there is no photoelectric effect. The meaning is nu 0 is the starting frequency for the photoelectric effect. So this frequency is the minimum frequency below which there is no photoelectric effect. Also I had explained about the work function phi 0. What is work function? These valence electrons are bound to the metal surface. A certain minimum energy is required to just free the electron, and this minimum energy required to just liberate an electron from the metal surface is called as the work function phi 0. So just now we have seen E is equals to h nu. Therefore you can write the energy phi 0 as h nu 0. Why? Because phi 0 is the minimum energy just required to liberate an electron, and nu 0 is the minimum frequency at which photoelectric effect takes place. So we have the relation phi 0 is equals to h nu 0. Now let us consider the photoelectric effect. What happens in photoelectric effect? Radiation is incident on the valence electrons and the electrons are emitted out. So here just now we have seen that radiation is made up of packets of energy. So let us take one such packet of energy, that is a photon, and it carrying energy E. So this photon is incident on the electron. Actually the photoelectric effect is an elastic collision between the photon and the electron. So what happens in this collision? The energy of the photon E is completely absorbed by the electron. What for the energy is used? So this energy E, which is absorbed by the electron, is used in two ways. One is to just make the electron free, and that is nothing but your work function phi 0. And the remaining energy appears as the maximum kinetic energy of the electron. So part of the energy is used to just make the electron free, and the remaining energy is kinetic energy of the electron, maximum kinetic energy. Therefore, you can write the relation for E is sum of phi 0 and k max, or E is equals to phi 0 plus k max. If you take k max on one side, k max will be nothing but E minus phi 0. Put the value of E. E is nothing but energy of the incident photon, that is h nu. So k max will be h nu minus phi 0. You can also write this equation in yet another way. Phi 0. Phi 0 I have told you it is h nu 0. If you put the value of phi 0, it becomes h nu minus h nu 0. Take out h common. You will have another equation for k max. Kmax is h into bracket nu minus nu 0. So what is the formula for Kmax? Kmax is nothing but the kinetic energy with which the electron moves. The formula for kinetic energy is half mv square. Because it is maximum kinetic energy, we put the maximum velocity here. So Kmax is given by half m Vmax square, where Vmax is the maximum kinetic energy of the emitted electron. So this is about Einstein's photoelectric equation. Now we shall write down some properties of a photon. So what are the properties of a photon? Let us begin with the first property. Already we have written energy of a photon is given as E is equals to h nu. This equation shows that E is proportional to nu. So second property is E proportional to nu. That is, energy of a photon is directly proportional to the frequency of radiation. But it does not depend upon the intensity of radiation. It depends only on the frequency of radiation. Then the photon travels with the velocity of light. That is, C equals to 3 into 10 raised to 8 meter per second. Then it is uncharged or a neutral particle. It is not deflected by electric and magnetic fields. Then the rest mass of a photon is 0 and the momentum of a photon is given as P is equals to h nu upon C. Then let us consider the photon particle collision. Just now we have considered photon electron collision. Just in general, in any photon particle collision, that is in any collision between a photon and a particle, it is an elastic collision, therefore energy and momentum are conserved, but the number of photons may not be conserved. That is, photon can be absorbed or a new photon can be created. Number of photons is not conserved, but energy and momentum are conserved. So these are some of the properties of a photon. So let us revise what we have done just now. First we have framed Einstein's photoelectric equation. For that we have used quantum theory of radiation, and according to quantum theory, radiation is made up of discrete packets of energy or particles called as photons or quanta, and the energy of each photon is given as E is equals to h nu. Now in photoelectric effect, a photon is incident on a valence electron. The energy E of the photon is completely absorbed by the electron. This energy is used in two ways. Part of the energy is used to just make the electron free. That is nothing but your work function phi 0. And the remaining energy appears as maximum kinetic energy of the electron Kmax. So we have a relation E is equals to phi 0 plus Kmax, or Kmax is equals to E minus phi 0. If you put the value of E as h nu, you will have Kmax is equals to h nu minus phi 0. And if you put the value of phi 0 as h nu 0, you can write Kmax is equals to h into bracket nu minus nu 0. So this is about Einstein's photoelectric equation. Then we have written down some properties of a photon. What are the properties? Energy of a photon is given as E is equals to h nu. It shows that energy is directly proportional to frequency but independent of intensity. Then photon travels with the velocity of light. It is a neutral particle. Its rest mass is 0. The momentum is given as h nu upon c. And in a photon particle collision, energy and momentum are conserved, but number of photons is not conserved. So both the points are important from your exam point of view. Let us now study how Einstein explained the photoelectric effect using his photoelectric equation. So in the previous class we had studied the observations of photoelectric effect. So let us explain the observations one by one using Einstein's photoelectric equation. So the first observation we had studied was photoelectric effect is instantaneous. So just now we have seen that radiation is made of packets of energies called as photons or quanta. So when a photon is incident on an electron, there is an immediate transfer of energy from the photon to the electron, and the electron is emitted out. And because of the immediate transfer of energy, we can say that the photoelectric effect is instantaneous. The next observation was current is directly proportional to the intensity. So let us define intensity in terms of the number of photons. So intensity is defined as the number of photons incident on the emitter per unit area per second. Now what happens if the intensity increases? If the intensity of the falling radiation increases, then what happens? The number of photons will also increase. Now one photon will emit one electron. So if the number of photons incident on the emitter increases, the number of electrons emitted out from the emitter also increases. So if the number of electrons emitted from the emitter increases, what happens to the current? You know how to define current? Current is nothing but rate of flow of charge. That is I is equals to Q upon T. So here Q will be equals to NE, where N is the number of electrons emitted and E is the electronic charge. The meaning is one electron has got the charge E. Therefore N number of electrons will have a charge Ne. So you can say that I is equals to Ne upon T. So if N increases, that is if the number of electrons increases, what happens to the current? The current also increases. So what is the conclusion? If the intensity increases, the number of photons incident on the emitter increases. Therefore, the number of electrons emitted out from the emitter increases. Therefore, the current also increases. That is, current is directly proportional to the intensity. So this is the second observation of photoelectric effect. Then the third observation we had studied was the stopping potential, or equivalently you can call it as maximum kinetic energy. So maximum kinetic energy is directly proportional to the frequency of radiation and it is independent of the intensity of radiation. Now let us consider the Einstein's photoelectric equation which we have derived just now. The equation is Kmax is equals to h nu minus phi 0. So for a given metal, the work function phi 0 is constant. Therefore, Kmax is directly proportional to nu because h is again a constant. The meaning is the maximum kinetic energy is directly proportional to the frequency and there is no term for intensity. So it does not depend upon the intensity of radiation. Now the next observation, that is for a given metal, there is a certain minimum frequency of incident radiation below which there is no photoelectric effect. And this minimum frequency, we call it as the threshold frequency denoted by nu 0. So let us explain this threshold frequency based on Einstein's photoelectric equation. So let us take the other form of Einstein's equation. Kmax is equals to h into bracket nu minus nu 0. Now we shall study three different cases. First we shall take nu less than nu 0. So if nu is less than nu 0, what will happen? This difference will be negative. Therefore, Kmax also will be negative. What is the meaning? The kinetic energy of the electron is negative. So this has no physical meaning. Therefore, photoelectric effect is not possible. There is no photoelectric effect if nu is less than nu 0. Now let us take the second case. Nu is equals to nu 0. This is the second case. If nu equals to nu 0, what will happen? If nu is equals to nu 0, this difference will be 0. Therefore, Kmax will be also equals to 0. So what is the meaning of this? The electron is just released from the metal surface, but its kinetic energy is 0. Means the electron does not move. It is released from the metal surface, but it does not move. Then the third case, nu is greater than nu 0. If nu is greater than nu 0, this difference will be positive. Therefore, Kmax also will be positive. That is, the maximum kinetic energy of the electron is positive. The meaning is there is a photoelectric emission. So when is photoelectric effect not possible? If nu is less than nu 0, there is no photoelectric emission. So what is the meaning of this? There is a certain minimum frequency nu 0 below which there is no photoelectric effect, and this minimum frequency we call it as the threshold frequency. So this is how we explain the results of the photoelectric effect using Einstein's photoelectric equation. So let us summarize it once again. First observation, photoelectric effect is instantaneous. So when a photon collides with an electron, there is an immediate transfer of energy from the photon to the electron, and the electron is emitted out. And therefore we say that the photoelectric effect is instantaneous. Second observation, photoelectric current is directly proportional to intensity. What is intensity? Intensity of radiation is nothing but number of photons incident on the emitter per unit area per second. So what happens if the intensity increases? If the intensity increases, number of photons incident on the emitter increases. Therefore, number of electrons emitted out from the emitter also increases. Therefore, the current also increases. So we can say that if intensity increases, current also increases, or current is directly proportional to the intensity. Third observation, maximum kinetic energy is directly proportional to frequency and it is independent of intensity. So we have Einstein's equation, Kmax is equals to h nu minus phi 0. For a given metal, phi 0 is constant, h is also a constant. So this equation clearly shows that Kmax is directly proportional to the frequency. It only depends upon the frequency. It does not depend upon the intensity of radiation. Then the next observation is that for a given metal, there is a certain minimum frequency of incident radiation below which there is no photoelectric effect, and this minimum frequency is called as the threshold frequency. So let us consider Einstein's photoelectric equation in another form. Kmax is equals to h into bracket nu minus nu 0. So we have studied three different cases for that. First one, nu less than nu 0. If nu is less than nu 0, the difference is negative. Kmax is negative. This has got no meaning. Therefore, photoelectric effect is not possible. Second case, nu is equals to nu 0. Then this difference will be equals to 0. Therefore, Kmax is equals to 0. The meaning is the electron is just released, but its kinetic energy is 0. It does not move. Third case is nu is greater than nu 0. If nu is greater than nu 0, the difference is positive. Therefore, Kmax is also positive. The meaning is there is photoelectric effect. So when is photoelectric effect not possible? If nu is less than nu 0. The meaning is there exists certain minimum frequency nu 0 below which there is no photoelectric effect, and this minimum frequency is called as the threshold frequency. So this is all about Einstein's explanation of the photoelectric effect, or you can also say like this. This is Einstein's explanation of the results of the photoelectric effect. So this question is important from your exam point of view. It will be asked for 5 marks. So this is all for today's session. Thank you.